Alright, today we're in section 4.5, Rules of Exponents. Section 4.5, Rules of Exponents. We're on page 194 in our books. Okay, in example 1, we start off with a word problem, but let's just break it down and we'll kind of pull out what the important parts are. Okay, in the word problem it says that you have a lake, Powell, that is a reservoir behind the Glen Canyon Dam in Arizona. And it can hold about 10 to the 12th power cubic feet of water when it's full. Well, there's about 10 to the 27th power water of molecules in 1 cubic foot of water. So here's the question. About how many water molecules can the reservoir hold? All right, well, 10 to the 12th power. Does everybody agree that's a pretty big number? Yes. You agree? 10 to the 27th power, that's an even bigger number. Now, here's what we can do whenever we have numbers being multiplied that have really large exponents or even smaller exponents. I write 10 to the 12th power times 10 to the 27th power. Well, here's what my product of powers property says. My product of powers property says that if I have the same base, whether it's a number or a variable, if I have the same base, I can add my exponents together. Does everybody agree that I have the same base? It's 10 in both numbers. Since I'm multiplying, I can add my exponents. 10 to the 12th plus to the 27th would equal 10 to the 39th power, and I would label it molecules, which I'm going to have to abbreviate because I'm running out of room. All right, so my product of powers property, again, this is what it says. If I have the same base, I can add, and I'm multiplying, I can add my exponents together to find my product. All right, product of powers property. All right, so let's work a few of these problems not in a word problem type of format. All right, let's see, let's do 9 to the second times 9 to the third. Do you agree that you have the same base? Yes. Okay, so since you have the same base, that's basically like saying, and I want you to write this in your notes, okay? That's basically like saying 9 to the second plus 3, 9 to the 2 plus 3, which equals what? 9 to the 5th power, okay? This step, I just want you showing, at least for now, because I want to see that you understand what you're doing with your exponents. Does that make sense? Now, do I think that you can do 2 plus 3 in your head? Yes. Yeah, of course you can do 2 plus 3 in your head, but I just want you to show that because I want you to see what you're doing. Same base. Since you're multiplying, you're going to add your exponents together. All right? Okay, now let's do another one. What if I had 8 times 8 to the 5th? Okay, so since there's no exponent here, that's just a 0, right? No, it's a understood 1. So remember, whenever a number does not have an exponent, we know that that's an understood 1. Okay? And now let's multiply it by another number. Well, can I multiply it by 3 numbers as long as they have the same base? Can I still use my property? Absolutely. Okay, so now remember, that blank space, that's an understood 1. All right, so now I can add all of my exponents together. So I would have 8 to the 1 plus 5 plus 2. So it's 8 to the 8th power. 8 to the 8th power. All right, again, on your homework, I do want you showing this step, not necessarily because I don't think you can add 2 plus 3 in your head, but just because I want to see that you understand the process. Does that make sense? Okay. All right, Amelia? All right, so what if I had 7 to the 6th power times 8 to the 7th power? Could I apply my product of powers property? Why not? Because it's not the same base. It's not the same base. I have a base of 7 and a base of 8, so I cannot apply my product of powers property. So, Colin, this goes along with the question you asked. Now I have to evaluate my exponents to solve. Okay? But I can use my product of powers property as a shortcut when I have the same base. Make sense? Okay, when I'm multiplying. Wyatt, you with me? Okay. So now let's practice. Okay? Example 1, checkpoint. All right, I want you guys working these problems. Yeah, so work them real quick. I'll give you a couple minutes. All right, so the answer to the first one, what'd you get? 2 to the 5th power. Okay, and remember I want you writing in your work 2 to the 3rd plus 2. 2 to the 3 plus 2, and then that's your answer is 2 to the 5th. All right, so on your second problem, it's 8 to the 7 plus 5, right? And what's your answer? 8 to the 12th. On your third one, it's 5 to the what? 1 plus 2, which is 5 to the 3rd power. Very good. And then on your last one, that would be 4 to the 6 plus 4 plus 3, which is 4 to the 13th. All right, who got them all? Awesome, very good. Okay, so product of powers property. What does product mean? What operation? Multiplication. So when I'm multiplying numbers with the same base, I add their exponents, and that's my product of powers property. So now let's look at what if we are using some variables. Well, my product of powers property still applies. All right, so does everybody agree that I have the same base here? They're both x's, right? Yeah. So since they're both x's, I can apply my product of powers property. So x to the 6 plus 9 is what? 15. X to the 15th. And that's my final answer. I don't have a value for x, so that's what I put. Now, on the second one, we can think of this as, we can split these terms. 3 times x and 5 times x times 5 times x. Okay? Well, when I split this, can I do 3 times 5? Can I do 3 times 5? Yeah. Oh, this should be x to the 5th. This 5 got messed up. X to the 5th. All right, so 3 times 5 is what? What's 3 times 5, guys? 15. It's 15. And remember, our commutative property of multiplication says that we can multiply in any order. So can I multiply 3 times 5 first? Yeah, sure. Multiply my numbers first to get 15. And then can I apply my product of powers property to my x's? Yeah, it's the same variable. It's the same base. So what's x times x to the 5th? X to the 6th power. Okay? So when you look at these terms, remember that you can split these. You can do 3 times 5, and then you can use your product of powers property to multiply your x's. All right, so now on the third one, can I multiply my numbers together? 2 times 7? Yeah. All right, what do I get? 14. 14. Can I use my product of powers property with my y's? Yes, so that would be y to the 5th power. Remember, when I'm multiplying variables or numbers with the same base, I add my exponents. I don't multiply them. I add them together. So 14y to the 5th. Who got that one right before we wrote the answer? All right, awesome. Good job, guys. Okay, so now that was product of powers property. Now let's talk for a minute about the quotient of powers property. Well, if product meant multiplication, what do you think quotient means? Division. Okay, so if with a product of powers property we add, what do you think we're doing with quotient of property? And we're subtracting, okay? And here's what the property says. As long as the number is not 0, it can't be 0, what I do when I have the same base is I subtract my exponents. What is also important is that you subtract the top number minus the bottom number. Do you see what I did here? Okay, and this is the work right here that I want you showing on your homework tonight. 6 to the 8 minus 5. Do I know that you can do 8 minus 5 in your head? Well, of course. Okay, I know you can do 8 minus 5 in your head. But I want to know, be able to see in your work that you understand the process of applying this property. Okay? All right, so quotient of powers. How does it look in a problem? Well, we have 7 to the 6th divided by 7 to the 2nd. Does everybody agree that we have the same base? Yes. Good? We have the same base. The base is 7. So 7 is my common base to the 6 minus 2. Okay, I want you to write that in your exponent. Well, what is 6 minus 2? 4. What is it? 4. So 7 to the 4th power is my answer. Again, I know I keep saying this, but make sure you show this work on your homework. All right, now look at the second one. Now, again, I have a monomial. I have a number and a variable combination. Well, can I reduce 4/10? Can I reduce it? Of course I can. I can reduce 4/10 to what? 2/5. Okay, and now can I apply my quotient of powers property to my x's? I can. So in my numerator, I'm going to do x to the 8 minus 2. It is in my numerator because I always subtract the numerator minus the denominator. I'm basically bringing that number in the denominator up to the numerator. All right, so now what is 8 minus 2? So 2x to the 6th over 5. Or 2/5, x to the 6, I guess you could say. It's 2x to the 6 divided by 5 is how you would say it. All right, now I want you to try the third one on your own. Can I reduce 5/7? No. So I just leave it like that, and then I have x to the third minus what? Minus 1. So I end up with 5x squared divided by 7. Who got that right? Who got it right? Awesome, guys. Good job. All right, so now let's do plenty of practice, okay? Going back to the multiplication, I don't necessarily have to write the original problem because I want you working through these quickly. On your homework, you do, but just show me what you're adding. Well, that's kind of weird. Anyway, show me what you're adding and then tell me the answer. All right, so b to the 7th times b to the 2nd equals b to the 7 plus 2, which is what? B to the 9th. Very good. All right, now what about a times a squared? It would be a to the 1 plus 2, which is a to the 4th. All right, what about the third one? 2n to the 11th times 6n to the 8th. 2 times 6 is 12 to the n, 11 plus 8. So it's 12n to the 19th. All right, and then on the last one, 2 times 7 is 14 to the m, 4 plus 5. So it's 14m to the 9th. All right, who got them all right? All 4? Okay. All right, if you missed one, do you see where you went wrong? Any questions? All right, now let's do some division. All right, let's practice some division now. Go ahead and work these. Okay, so now we have 6 to the 9 minus 4. 6 to the 9 minus 4 equals what? 6 to the 5th, right? 6 to the 5th. 10 to the 11 minus 7 is? 10 to the 4th. Z to the 8 minus 3 is? Z to the 5th. And what about 12n to the 5th over 8n squared? Can I reduce that fraction? Yeah. Now leave it in proper. I had a couple people ask me that already. Leave it in proper. Don't change it to a mixed number. So it's going to be 3 to the n, at 3n to the 5th minus 2, which equals 3n to the 3rd divided by 2. All right. Who got all 4 of those right? Anybody get all 4 of those right? Maybe just didn't finish. Last example, example 4. In example 4, now it's a combination of both properties. Okay. What I have here is I have something that can be simplified in my numerator, and that 5 is 3m to the 5th. It's just misplaced a little bit. Okay. So what I have here is I have something that I can simplify my numerator before I divide. 3m to the 5th times m squared, well, I can apply my product of powers property to get 3m to the 7th. You see how I got that? Because 5 plus 2 is 7. Now I divide that by 6m to the 3rd, and now I can apply my quotient of powers property. So can I reduce 3/6 to 1/2? And now I have m to the 7 minus 3, so I have 1m to the 4th over 2. Now let me ask you this. Do I technically need my 1 in front of the m? No. Now if the 1 was all by itself in the numerator, I would need it. But the correct answer, now if you keep the 1 there, I'm not going to mark off for that. But the proper way to write it is without the 1 because I know it's understood. All right, now again, if you write it like this on a quiz, I'm not going to mark off for that. No, I just said that. All right. Okay, so now on your second one, can you simplify anything in your numerator? Yeah, you can use your product of powers property for your a's. So 14 a to the third plus 3 plus 2 is what? 14 a to the fifth, right? Now I bring over my denominator over 7a. Can I simplify 14 over 7? Yeah. To what? 2 a to the 5 what? 5 minus 1, right? Because I can apply my quotient of powers property to my a's. Do you see that, Zach? Do you see what I'm doing there? I'm applying my quotient of powers property to my variables. All right, so can I do 5 minus 1? Yeah, of course. 2a to the fourth. All right, I want you to try the third one on your own. All right, so can I use my product of powers property for my c's? 5c to the 7 plus 2, right? So that's 5c to the 9th over 15c to the third. So that's going to be 1/3 c to the 9 minus 3. So now I have the same thing again, 1c to the 6th over 3. Do I need my 1? So c to the 6th over 3. Now, am I going to mark wrong, Kenneth, if you do that? No, I won't mark it wrong, but the correct way to write it is without the 1. All right, now there's a couple different formats that you're going to see on your homework tonight, and you'll probably see this on a quiz or a test too. What if you had a problem like number 47 on your homework? Obviously this is an odd problem, so you don't have it, but you do have a couple that are like this. You have 4m to the fourth times n to the 7th m. All right, well, basically what you're doing is you're multiplying this term times the term on the inside. And you can apply your product of powers property, but can you apply the m and the n? Can you add 4 plus 7? No, and that's what we were talking about earlier. What can you do? You can combine, yes, these m's. So 4 times, is there any numbers inside? Are there any numbers inside the parentheses? No, it's just 1. So it's going to be 4, m to the, you already said it, m to the 5th, and then, can I multiply my n by anything? No, so it's just n to the 7th. All right, do you see how we did that? Okay, now what if you had one like number 57? On number 57, you have 2w to the 6th times 36w to the 8th over 18w to the 4th. All right, I want you to try to solve this one on your own, and then we'll check it. All right, what's 2 times 36?
72.
72. I can apply my product of powers. What is w to the 6 plus 8? W, what's 6 plus 8? 14. All right, now over 18w to the 4th. All right, 72 divided by 18 is 4. And then to the w minus 14 minus 4 would be 10. 4w to the 10th. All right, who got that right? 4w to the 10. Zach, awesome. Hayden, great job. Good job, guys. Isaiah, Colin. All right, any questions? Any questions? All right, one of our longer lessons, but rules of exponents are very important. So hopefully you understand everything. If you do, then that's everything you need to know for 4.5.